Good morning, parents, teachers, and learners. Welcome back to our Mathematics 9 Valenzuela Facebook Live. We are now on quarter 3, week 6, wherein we will discuss similar figures and similar triangles. Let me present to you our objectives for today. At the end of the discussion, you should be able to, number 1, illustrate similarity of figures. The second one, solve for the angle measures and lengths of sides of similar figures. And lastly, prove conditions for similarity of triangles using AA similarity theorem, SAS similarity theorem, and SSS similarity theorem. Please be ready with your ADM or modules and turn it on page 22. Please make sure that your pen and paper are with you for solving and taking down notes purposes. Before we proceed to the topic, let us have a short story about Kaloy. This will serve as a review of some related topics that we need for today's discussion. The title of the story is Kaloy, the Street Runner. Let us witness how will the story go. This is Kaloy. He is the protagonist in our story. He is a grade 9 student in Polo National High School. Kaloy, a grade 9 student, enjoys solving math problems. In fact, he always participates with the class discussion and the Valenzuela FB live streaming sessions. He is not only good in math, but also in other subjects. One morning, after playing the guitar, he attempted to jog outside their home. As he jogs, he noticed that the surrounding became quiet and strange. Suddenly, he is shocked that a gigantic COVID-19 virus appeared at a distance and now trying to catch him. He forgets that the IATF guidelines bawal lumabas. Only one solution is rightful to do, and that is to go back home. But as he turns, checkpoints are already placed outside the streets. And the only way to pass these checkpoints is to answer math questions. Are you ready to help him lead his way back home? That's great! We need to answer the questions in each checkpoint. The correct answer that corresponds to the right color of the path will lead him to his home. And we are only given 10 seconds to place our answers in the comment section. So let us start. Question number 1. Which of the following is a proportion? For the red path, 3:4 and 4:3. For the blue path, 2:3 and 4:6. Which is the correct path Kaloy should take? 10 seconds. Go. If you answered the blue path, you are correct. Let us recall that proportion are equal ratios. To determine if the given are proportion or not, we need the means and extremes theorem. It states that two ratios are proportion if the product of the means is equal to the product of the extremes. One of the choices is 3:4 and 4:3. If we multiply the means, 4 times 4 will give us the product of 16. If we are going to get the product of the extremes, 3 times 3, that will be 9. 16 is not equal to 9. So therefore, we can say that it is not a proportion. The second choice is given by 2:3 and 4:6. Multiplying the means, 4 times 3, that will give us the product of 12. Multiplying the extremes, 6 times 2 or 2 times 6, that will give us the product of 12. It will result to 12, which is equal to 12. So therefore, we can say that the ratios in the blue path is the correct answer. We already passed the first checkpoint. but the coronavirus still follows Kaloy. Let us continue helping Kaloy so that we can lead him back home. Let us proceed to the second question. Solve for the value of x in the proportion 2x over 3 is equal to the binomial x plus 7 all over 5. For the red path, x is equal to 7. For the blue path, we have x is equal to 3. Which path should we choose? Is it the red or the blue path? Your timer starts now. If you got x is equal to 3, you are awesome. It seems that you can still remember how to solve for the value of the unknown variable in proportions. So to recall, in finding the value of the unknown in proportions, we need again your means and extremes theorem. So out of the given proportion, we need to get the product of the extremes. So that will be 2x times 5 is equal to the product of the means, which will be 3 times the binomial x plus 7. Multiplying 2x times 5, that will be 10x, is equal to 3x plus 21 after applying distributive property. Then we apply addition property of equality by adding negative 3x to both sides of the equation. Hence, we have 10x minus 3x is equal to 21. Simplifying this equation, we will be having 7x is equal to 21. Divide both sides by 7. Therefore, we have x is equal to 3. A few more questions before we can lead Kaloy to his home. I hope that you are still with us in this challenge. Let us proceed to checkpoint number 3. Question number 3. If triangle ABC is congruent to triangle DEF, which side corresponds to segment AC? Should we choose the blue path with segment DE or the red path with segment DF? I hope that you can still remember your grade 8 lesson about the correspondence of parts of congruent triangles. 10 seconds on the time, go. If you will lead him to the red path, that's incredible. To recall, in determining the correspondence of sides, we should consider the proper correspondence of the vertices first. Vertex A corresponds to vertex D. Vertex B corresponds to vertex E. And vertex C corresponds to vertex F. After we know this concept, we can say that segment AC corresponds to segment DF. Remember, the order of the vertices is important. What an awesome memory! The concept of the correspondence or pairing of the vertices as well as the parts of the polygon will be used for the discussion later. We are now on the last checkpoint. Question number 4. Given the figures, what is the ratio of the lengths of segment AP to segment CM? Should he take the red path with the ratio 1:3 or the blue path with the ratio 3:1? Your timer starts now. If you answer the red path, that's magnificent. To get the ratio of segment AP to segment CM, we need to consider the length of each side of the triangles. Remember that segment AP measures 5 and segment CM measures 15. We are asked to get the ratio of AP is to CM. The ratio will be 5 over 15. Which can be simplified as 1/3. since both of the terms, numerator and denominator, are divisible by 5. So therefore, we can say that the ratio of AP is to CM is equal to 1 is to 3. That's intense. Thank you for helping Kaloy. We already sent Kaloy home. Please always remember to stay at home during this pandemic. Be cautious and stick with the guidelines that are provided by the IATF, most especially the minimum health protocol. Remember that our simple acts can contribute greatly to stop the spread of the COVID-19 virus. It seems that you have done a great job remembering the past lessons that you have about ratio and proportion, and the concept that you applied on congruent triangles. At this point, let me ask you the following questions. Have you ever tried to copy an image by drawing using scale? Did you experience having a task where you need to copy a smaller drawing and turn it to its bigger version? Have you ever made a sample blueprint of a park in Valenzuela, like the Valenzuela City Sports Park? Or how about any structure your dream house may be? How big is your living room? Where is the master's bedroom located? Or have you ever tried to make a miniature of a structure? Have you seen the miniatures of hotels and condominiums in some malls? Did you know that in Museo ng Valenzuela, you can find a life-size image of Kartong Bato? As I mentioned, those concepts that we have in the previous activity will be used as we discuss similar figures and similar triangles. And these questions that I presented you a while ago are some of their applications. But when can we say that figures are similar? A figure is similar to another if and only if the following conditions are satisfied. The first one, corresponding angles are congruent. And the second one, corresponding sides are proportional. We should make sure that the two conditions are satisfied in order for us to say that the figures are similar. Similar figures are also denoted by this symbol. It is called tilde. Let us have some examples. Example number 1. Suppose that quadrilateral ABCD is similar to quadrilateral WXYZ. Determine the pairs of congruent angles and proportional sides. First, it is important to know the correspondence of the vertices before naming the pairs of angles and sides. It requires the proper pairing of vertices from one figure to another one. Vertex A of quadrilateral ABCD corresponds to vertex W of quadrilateral WXYZ. Vertex B corresponds to vertex X. Vertex C corresponds to vertex Y. And lastly, vertex D corresponds to vertex Z. After knowing the correspondence or the proper pairing of the vertices, correspondence or pairing of angles and sides can be made. We should take note that the order of the vertices is important when naming corresponding sides and angles. Angle A of quadrilateral ABCD corresponds to angle W. Based on the definition of similar figures, their corresponding angles must be congruent. So therefore, we can say that angle A is congruent to angle W. Next, angle B corresponds to angle X. So therefore, we can say that angle B is congruent to angle X. Angle C corresponds to angle Y. Therefore, we have angle C is congruent to angle Y. And lastly, angle D in quadrilateral ABCD corresponds to angle C of quadrilateral WXYZ. So therefore, we can say that angle D is congruent to angle Z. After enumerating the congruent angles, let us have the correspondence of the sides and their relationship. Side AB of quadrilateral ABCD corresponds to side WX of quadrilateral WXYZ. Hence, we can say that we can make the ratio AB over WX. Segment BC or side BC corresponds to side XY. That has the ratio BC over XY. Side CD corresponds to side YZ, having the ratio CD over YZ. And the last pair of sides, side DA corresponds to side ZW. Thus, we have the ratio DA is to ZW. Let us get the ratios made. Based on the definition of similar figures, the sides are proportional. So we can say that the ratios are all equal. There. Since quadrilateral ABCD is similar to quadrilateral WXYZ, the following corresponding angles are congruent. And the ratios of the sides form a proportion. Let us now proceed to another example. Example number 2. Given triangle DEF is similar to triangle ABC, determine the congruent angles and proportional sides. In order for us to determine the congruent angles and proportional sides, let us make sure the correspondence or pairing of the vertices. Vertex D corresponds to vertex A, vertex E corresponds to vertex B, and vertex F corresponds to vertex C. From the statement, triangle DEF is similar to triangle ABC, and the correspondence of the vertices, we can name the pairs of corresponding angles that are congruent. The first pair, angle D, is congruent to angle A. Next, angle E is congruent to angle B. And the last one, angle F, is congruent to angle C. Now, let us have the ratios of the sides. Let us have the first ratio, DE over AB. The ratio of the sides, EF over BC. And the last ratio can be made between the sides DF and AC. Since the two triangles are similar, the ratios of the sides are equal. Let us now go to example number 3. Triangle OBS is similar to triangle XYZ as shown in the figure. Find the measure of angle O, angle B, angle S, the length of OB, and the length of YZ. From the similarity statement and the figures, we can say that vertex O corresponds to vertex X. Vertex B corresponds to vertex Y. And lastly, vertex S corresponds to vertex Z. Hence, we can say that angle O is congruent to angle X. If angle X is 30 degrees, we can say that angle O is also 30 degrees. Next, angle B is congruent to angle Y. If the measure of angle Y is 70 degrees, therefore we can say that angle B also measures 70 degrees. Lastly, angle S is congruent to angle Z. If angle Z measures 80 degrees, therefore we can say that angle S also measures 80 degrees. Still working on the same problem, let us find the measures of the missing sides. How are we going to find the lengths of OB and YZ? At this point, we need the scale factor. What is a scale factor? It is the ratio of the length of one side of a figure to the length of its corresponding side of the other figure. The symbol used to represent the scale factor is K. Note that the two triangles are similar, so we can form a proportion out of the ratios of the sides. We obtain OB over XY, BS over YZ, and SO over ZX. The ratios are equal. Then let us substitute the given measures. OB measures OB, while XY measures 16. That is why we have OB over 16. Next, BS, we have the measure 5. YZ is missing, so it is still YZ. And the last one, SO measures 7 and ZX measures 14. That is why we have 7 over 14. We need to consider and identify the ratio of the known corresponding side lengths that can be used in solving for the unknown lengths of the other sides. Hence, we can use the ratio of SO over ZX, which is equal to 7 over 14. And if we are going to simplify, that would just be equal to 1/2. Out of the scale factor, we can get the missing side lengths. Let us have the length of OB. We need to form a proportion using the ratio that has the side OB in it and the scale factor. So therefore, we will be using OB over XY and SO over ZX. Let us equate them. Substituting the values of the lengths, we will obtain OB over 16 is equal to 1/2, which is our scale factor. Applying the means and extremes theorem, we will multiply OB times 2. It should be equal to the product of 16 times 1. The result is now 2OB is equal to 16. To get the length of OB, we divide both sides of the equation by 2. Therefore, the length of OB is 8 units. Now, let us find the length of the last side, which is YZ. Again, we need to form a proportion using the ratio that has side YZ in it and the scale factor. So it will be the ratios BS over YZ and SO over ZX. Let us equate them. Substituting the lengths of the sides, we will obtain 5 over YZ is equal to the scale factor 1/2. Applying the means and extremes theorem, multiplying 5 times 2 is equal to the product of the means. That will be YZ times 1. Simplifying, the result will now be 10 is equal to YZ. So therefore, by symmetric property, YZ is equal to 10 units. Next, let us proceed with example number 4. If quadrilateral ABCD is similar to quadrilateral EFGH, find each of the following. Number 1, the scale factor of ABCD to EFGH. The second one, the length of EF. Next, the length of FG, the length of GH, the perimeters of ABCD and EFGH, and the ratios of the perimeters of ABCD to EFGH. Let us determine the proportion that can be formed using the ratios of the sides of the two similar quadrilateral. For us to find the scale factor, we will be having the ratio of AB over EF. That should be equal to the ratio BC over FG and equal to the ratio CD over GH and DA over HE. Next thing to do is to substitute their respective measures. AB is 24 and EF is X. That is why we have 24 over X. Next, BC is 12 and FG is Y. That's why we obtained 12 over Y. CD is 20 and GH is Z. That is why we have 20 over Z. And the last one, DA measures 8 and HE measures 6. That is why we have 8 over 6. The scale factor that we can use is the ratio, correct, DA over HE, which is equal to 8 over 6. This has the lowest term, 4/3. Out of this scale factor, we are now ready to find the measures of the lengths of the missing sides. Let us find the length of EF. We need to find the ratio with EF in it. So we will be using, correct, AB over EF and equate it to our scale factor, dA over HE. Substituting the measures, that will become 24 over x is equal to our scale factor 4/3. Applying the means and extremes theorem, 24 times 3 must be equal to the product of x times 4. By multiplication, we have 72 is equal to 4x. We need to divide both sides of the equation by 4 for us to get the value of x. The result is now, great, 18 is equal to x. By symmetric property, we obtain the value of x, which is equal to 18. Since x stands for the length of EF, therefore we can say that EF measures 18 units. Now, let us proceed in finding the length of FG. Same process will be used. What pair of ratios are we going to use? That's correct. We will be using BC over FG and equate it to the scale factor dA over HE. Next, let us substitute the lengths. We now have 12 over y is equal to the scale factor 4/3. Applying the means and extremes theorem, 12 times 3 must be equal to the product of y times 4. By multiplication, we have 36 is equal to 4y. Divide both sides by 4 for us to get the value of y. The result is now, very good, 9 is equal to y. By symmetric property, we obtain the value of y, which is equal to 9 units. Since y stands for the length of FG, therefore we can say that FG measures 9 units. Let us solve for the length of the last side, and that is side GH. To find the length of GH, we need to find the ratio with side GH in it. So that will be CD over GH. And we need to equate that to our scale factor, dA over HE. Substituting the lengths, we have 20 over Z is equal to the scale factor 4/3. Next, let us apply the means and extremes theorem, multiplying 20 times 3. And it must be equal to the product of Z times 4. By multiplication, we will obtain 60 is equal to 4Z. We only need the value of Z. So therefore, we need to divide both sides of the equation by 4. The result will be, that's correct, 15 is equal to Z. So by symmetric property, we can say that Z is equal to 15 units. Since Z stands for the length of GH, therefore we can say that GH is equal to 15 units. For the next questions, we are asked to find the perimeter. To find the perimeter of any polygon, we need to add the measures of the sides of the following polygons. The of the quadrilateral ABCD is just adding 24, 12, 20, and 8. Adding them will result to 64 units. How about the perimeter of EFGH? What is your answer? Adding the sides, that will be 48 units. The last question, we need to find the ratio of perimeter ABCD over perimeter EFGH. The result will be 64 over 48. And if we are going to simplify this fraction, it is equivalent to 4/3. If you can observe, since the ratio of the perimeters is similar to the scale factor 4/3, we can now say that the ratio of the side lengths of two similar figures are proportional to the perimeters. I hope that you can still follow in our discussion. At this point, let us have a trivia. Did you know? Scouting was brought to the Philippines by American soldiers following their occupation of the country in the early 20th century. There were accounts of the presence of Boy Scouts in Manila as early as 1912. Plans of forming scouting troops for Filipino boys came from Miss Caroline S. Spencer, an American widow doing charity works with the natives in Cebu, with Lieutenant Sherman L. Keyser, a young second lieutenant assigned to arrange her transportation and accommodation for her charity work. So the source of this, scouts.org.ph. In line with this, a problem is presented. You, together with your troop members, went to camping to hone your survival skills. As night approached, the troop decided to build a lean-to shelter. Can you construct the right portion of the lean-to shelter so that it is similar to the left portion? Using the angles and the side legs as shown in the figure. For us to say that we can construct the right portion of the lean-to shelter similar to the left portion, we should show that the two triangles formed are similar. So, when can we say that triangles are similar? Just like triangle congruence, there are postulates, theorems that can be used to say that the two triangles are similar. So the two triangles are similar if they satisfy one of the following conditions or theorem. The first one, the AA similarity theorem. The second one, SAS similarity theorem. And the last one is the SSS similarity theorem. Let us discuss them one by one, starting with AAA similarity postulate, which serves as the foundation in proving the other similarity theorems. The AAA similarity postulate states that two triangles are similar if and only if their three corresponding angles are congruent. Remember that a postulate which is a statement accepted to be true without proof. So, no need to prove this one. Let us illustrate AAA similarity postulate. Consider triangle EFG and triangle XYZ. Based on the figure and their respective markings, we can see that angle E is congruent to angle X. Angle F is congruent to angle Y. And the last pair, angle G, is congruent to angle Z. Therefore, we can say that triangle EFG is similar to triangle XYZ using the AAA similarity postulate. We will use AAA similarity postulate to prove AA similarity theorem. Since it is a theorem, we need to prove it first. AA similarity theorem states that two triangles are similar if the two angles of one triangle are congruent to the corresponding two angles of the other triangle. Let us use triangle ABC and triangle XYZ. So we are given with angle A is congruent to angle X, angle B is congruent to angle Y. We need to prove that triangle ABC is similar to triangle XYZ. Let us use the two-column proof to prove this theorem. Let us start by citing angle A is congruent to angle X and angle B is congruent to angle Y. That is by given. So, if we are going to take a look at the figure, we now have angle X and angle A to be congruent. Next, angle B is congruent to angle Y. Our goal now is to prove that angle C and angle Z are congruent. Then we can say that the two triangles are similar because of the AAA similarity postulate. Next, the two pairs of angles are congruent as stated in statement number 1. So therefore, we can say that their measures are equal. Measure of angle A is equal to the measure of angle X, and measure of angle B is equal to the measure of angle Y. This is by definition of congruent angles. Note that if we are going to add the interior angles of each triangle, the result must be equal to 180 degrees. Thus, we can have the statement measure of angle A plus measure of angle B plus measure of angle C is equal to 180. So that is for the first triangle. Next, measure of angle X plus measure of angle Y plus measure of angle Z is equal to 180. So that is for the second triangle. That is because the interior or the sum of the interior angles of a triangle must be equal to 180 degrees. From the previous statement, we said that the measure of angle A is equal to the measure of angle X, as well as measure of angle B is equal to the measure of angle Y. Let us substitute the measures of angle X by measure of angle A. Next, let us substitute measure of angle Y by measure of angle B. So we now have the statement measure of angle A plus measure of angle B plus measure of angle Z is equal to 180. That is because of the law of substitution. Next, both sides of the equation are equal to 180. Hence, we can say or we can equate the two sides of the equation. Measure of angle A plus measure of angle B plus measure of angle C is equal to the measure of angle A plus measure of angle B plus measure of angle Z. The reason is transitive property of equality. Take note, if you will notice, both sides of the equation have measure of angle A and measure of angle B. It can be simplified as measure of angle C is equal to the measure of angle Z. What is the reason? We have the addition property of equality. Next, since the two angle measures are equal, we can say that they are congruent. We can say angle C is congruent to angle Z because of the definition of congruent angles. Lastly, the two triangles ABC and XYZ are similar. What is the reason for that? Because of AAA similarity postulate. We have already proven the first theorem on triangle similarity, which is the AA similarity theorem. Let us have an example. Let us determine if triangle JCP is similar to triangle RUS. As we can see in the figure, angle C and angle U have the same measures. Therefore, we can say that angle C is congruent to angle U. On the other hand, we need to solve for the measures of angle P or angle R for us to determine if triangle JCP is similar to triangle RUS by AA similarity theorem. In this example, let us find the measure of angle P. To get the measure of angle P, we need to add the measures of the interior angles of triangle JCP, the bigger triangle. So we have measure of angle J plus the measure of angle C plus the measure of angle P must be equal to 180. Next, we need to substitute the measures. We have 75 for the measure of angle J plus 70 for the measure of angle C plus the measure of angle P is equal to 180. 75 plus 70, that will be 145. And if we are going to use the addition property of equality by adding negative 145 to both sides of the equation, we will now obtain measure of angle P is equal to 180 minus 145. 180 minus 145 is equal to 35. Since the measure of angle P is 35, we can say that angle P is equal to 35 degrees. Since we have already two pairs of corresponding angles that are congruent, given by angle C is congruent to angle U, and the second pair, we have angle P is congruent to angle S. Therefore, we can say that triangle JCP is really similar to triangle RUS because of the AA similarity theorem. Let us proceed with the second theorem, known as the SAS similarity theorem. SAS similarity theorem states that two triangles are similar if two sides of a triangle are proportional to the corresponding two sides of the other triangle, and their corresponding included angles are congruent. Suppose we have triangle DEF and triangle ABC. Given that DE over AB is equal to DF over AC, so that will be the proportion made out of the ratios of the sides, and angle D is congruent to angle A, let us prove that triangle DEF is similar to triangle ABC. Before we proceed to the proof, on triangle ABC, let us locate point X. Locating point X such that segment AX is equal to segment DF. Then, let us locate point Y such that AY is equal to DF. Then let us connect XY so that we can form the segment XY here. Again, what we did is we let X and Y be on sides AB and AC respectively, such that AX is equal to DE and AY is equal to DF. Then we constructed segment XY. So we now produce this figure. Out of the new figure, let us plan on how are we going to prove that triangles DEF and ABC are similar. Targets, step number 1. Prove that triangle DEF is congruent to triangle AXY, or the two small triangles. After that, we need to prove that triangle AXY and triangle ABC are similar. Next, for step number 3, using the statements that we will make out of the two targets, we can prove that triangle DEF and triangle ABC are similar. So let us start the two-column proof. We begin our statement with we let X and Y be on sides AB and AC respectively, such that AX is equal to DE and AY is equal to DF, and we constructed segment XY. The reason is by construction. Remember that our first goal is to prove that triangle DEF is congruent to triangle AXY. Next, let us continue. Angle D is congruent to angle A, as stated in the given. From statement number 1, we said that AX is equal to DE and AY is equal to DF. Since their measures are equal, we can say that segment AX is congruent to segment DE and segment AY is congruent to segment DF because of the definition of congruent segments. Referring to the statements 2 and 3 and the markings on the figures, since we have two pairs of corresponding sides that are congruent and a pair of included angles that are also congruent, we can say that the small triangles, triangle DEF, is congruent to triangle AXY. The reason is SAS congruence postulate. By this, we are through with our first goal, which is to prove that triangle DEF is congruent to triangle AXY. Let us proceed to our second goal, to prove that triangle AXY is similar to triangle ABC. This time, let us use the given. DE over AB is equal to DF over AC. Using the equal segments that we produce in the construction part, AX equals DE and AY equals DF, let us substitute AX to DE and AY to DF. So therefore, we obtain the equation AX over AB is equal to AY over AC. The reason? Law of substitution. If you can see, the ratio of the side AX of triangle AXY and side AB of the bigger triangle ABC forms a proportion with side AY of triangle AXY and side AC of the bigger triangle ABC. Hence, we can say that segment XY is parallel to segment BC because if a line segment divides the two sides of a triangle proportionally, then it is parallel to the third side of the triangle. Out of the parallel sides XY and BC, we can say that the corresponding angles, angle AXY is congruent to angle ABC. The reason? The corresponding angles formed by two parallel lines cut by a transversal are congruent. Triangle AXY and triangle ABC have common angle, and that is angle A. So our next statement will be angle A is congruent to angle A. That is by reflexive property of congruence. As we can see in the figure, since we already have two pairs of corresponding angles that are congruent, we can now prove that triangle AXY is similar to triangle ABC. That is because of the AA similarity theorem. Let us now proceed with the last target. Going back with the statement, triangle DEF is congruent to triangle AXY given in the previous statement, which was proven by SAS congruence postulate. Since the triangles are congruent, we can also say that they are similar, making triangle DEF similar to triangle AXY. The reason? If two triangles are congruent, then they are similar. Let us observe closely statements 10 and 11. Triangle AXY is similar to triangle ABC, and triangle DEF is similar to triangle AXY. Since triangle DEF and triangle ABC are both similar to triangle AXY, therefore we can finally say that triangle DEF is similar to triangle ABC because of the transitive property of similarity. We already proved SAS similarity theorem. The last theorem for you to explore the way of proving is SSS similarity theorem. You may use the learning module as guide in proving this theorem. So the SSS similarity theorem states that if the corresponding three sides of two triangles are proportional, then the two triangles are similar. So let us illustrate. Suppose that we have triangle CAR and triangle LOS. If the ratios of the sides CA and LO is equal to the ratio of the sides CR and LS, and also equal to the ratio of the sides RA over SO, we can say that triangle CAR is similar to triangle LOS. That is by SSS similarity theorem. After knowing the theorems on triangle similarity as well as their respective proofs, let us answer the problem about the lean-to shelter. Can we construct the left and the right portions of it similarly? Take a look at the figure and their given measures. It can be seen that the measures of angle A and angle F are equal. So therefore, we can say that angle A is congruent to angle F, or angle BAC is congruent to angle GFH. Let us see if the ratios of the sides form a proportion. We have AB over FG is equal to AC over FH. Upon substitution, is 9 over 6 equal to 15 over 10? Upon simplifying, we will obtain 3 halves is equal to 3 halves. So therefore, we can say that triangle BAC is similar to triangle GFH because of SAS similarity theorem. Thus, The answer to the question is yes, we can make both portions similar. So let us sum up today's discussion. A figure is similar to another if and only if the following conditions are satisfied. Corresponding angles are congruent, and corresponding sides are proportional. Similar figures are denoted by this symbol, which is called as tilde. Next, in solving for the unknown side lengths of similar figures, scale factor is used. It is the ratio of the length of one side of a figure to the length of its corresponding side of the other figure. The symbol used to represent scale factor is K. Then, the last one. Two triangles are similar if they satisfy one of the following theorems or conditions. The first one, AA similarity theorem, SAS similarity theorem, SSS similarity theorem. If you have more questions and clarifications that needed to be answered, you may ask your respective math teachers during your math time. For your home learning task, the ways or approaches in achieving our goals in life might not be similar. One might achieve it fast, while others are still striving to reach the fulfillment of his dreams. You should keep your hopes high and make your outlook in life always positive. Maybe these are some similar traits of people beyond their success. We might be tired of everything we do. Well, that's normal. Take a rest. Pamper yourself for a while. But you should never give up. Who knows? Success is just a millimeter away from you. So this is Mr. Jude Carlo M. Pinapin, your live streaming teacher for today. Good day, stay safe, and God bless.